So let me start talking about cooperative flying robots. First of all, what is a flying robot? A flying robot, technically known as unmanned aerial vehicle, UAV, is basically an aircraft without a pilot. Nowadays, they are widely employed in missions in which it's better to avoid the presence of a human being. Just to give you an example, a few years ago when there was the earthquake in Fukushima, they employed these UAVs to pull down the nuclear reactor because it was bad for a pilot to go there due to radioactivity. So they are mainly divided in three groups. You can see in the first column fixed-wing UAVs, which are used for long distance, helicopter UAVs, which are used for short distance and they can carry heavy loads, so for example stopping a fire with a big tank of water, and multi-rotors, which are used in research. Why they are used in research? Because they are cheap, first of all, so you can crash them. They are small and they are very agile, which makes them very unstable, therefore challenging from a scientific point of view. So today we'll talk about multi-rotors and especially quadrotors, which you see up in the right. There is a multi-rotor with 4 propellers. So how does a quadrotor works? You see a bunch of math here involved. These math govern the equation of motions of the quadrotor. And basically, by varying the speed of each propeller, you can move this quadrotor. Now, this quadrotor can move in 2 ways. First way, remotely controlled. So there is a pilot on the ground with a joystick that moves the quadrotor around. The second way is autonomously. So there is a CPU on the quadrotor. You can install control algorithms on this CPU, and they accomplish tasks without any help of human being. And that's what we do. Particularly in our case, we install 3 different types of algorithm. Trajectory generation algorithm, which generates a path and gives it into a path following algorithm, which makes the quadrotor follow the path. Plus the cooperation algorithm, which gathers information from its own quadrotor plus other quadrotors and achieve coordination between them. So let's be a little bit more precise. There is a quadrotor at point A in a square room with a bunch of obstacles inside. So the trajectory generation algorithm generates a path which goes from A to B, and in the same time avoids the wall, avoids the obstacles, and minimizes the travel distance. After it, there is the path following algorithm that, with the help of the map, finds the velocity at which the propellers needs to rotate and makes the quadrotor follow the path. Now imagine that in this loop there are many quadrotors. The coordination algorithm makes the quadrotor coordinate between each other and adjust their speed so they coordinate. For example, arrive at the final destination at the same time. Few examples of coordination are coordinated exchange of position, in which the 2 quadrotors have to cross each other and arrive at the final point in the same time, or orbiting around 2 different circles while facing each other, or following lines of different length always facing each other, or maybe doing some fancy things as you can see there. Now this is the result of our simulation results, which we use to test the efficacy of the algorithm. But we implemented this video on real quadrotors, so I would like you to show part of the video. They will be the paparazzi of next generation. Okay, so far so good. Now what we have to recap. 2 quadrotors produces 2 trajectories, follow them, and coordinate with each other. Now let's try to see a little bit further. What if these quadrotors coordinate between each other and also with an external signal? which can be, for example, a car driving on the road, or a bird flying, or a beat, like a rhythm. I'm sure somebody of you has been dancing sometime. What happens when you dance? Let's say tango. There is a song, right? The man listens to the song and moves coordinating along with it. With the hand, he pushes the, I know because I've been dancing, I'm really bad, but he pushes with the hand of the woman, which knows which is the direction. So the woman moves accordingly with the man, and they end up doing this thing that is called dancing, right? Now, I've been many times dancing tango. I look like Pinocchio, like a piece of wood. I'm not good at it. But I said, well, I have now two robots which are able to coordinate, and they eventually can coordinate with an external signal, right? So what if I take this coordination algorithm and I combine it with what I like to do with myself, but I make it with the robots? So I took a tango song, I push it inside this MATLAB software, which we use for simulation and controlling, and this software gives me back the wave of the song. Now, quadrotor male, which is the blue one, listen to the song and coordinate with it. At the same time, quadrotor female, which is the red one, coordinate along with the male quadrotor, which is coordinating with the song. So what they do is exactly what you do when you go dancing tango. Quadrotor dancing tango. So that's it. I just would like to thank Nairo Bakimen, which is my advisor, Enrique Shargay, which is a colleague of mine and great friend, and Isaac Kamera and Vladimir Dobrokodov, former professor from Naval Postgraduate School. And of course, I want to thank you for listening to my talk and paying attention.